division. So this was the Bellinger question on in class. So I want you to go ahead and try it yourself using the lesson from last time for long division. So in this one, you should notice we have lots of missing terms. So we have w to the 5th plus 0w to the 4th plus 0w cubed plus 0w squared plus 0w plus 32. So there's actually lots of missing terms that I want you to go ahead and try out. So pause it, give it a shot, but we're going to get ahead. All right, so if we did this one correctly, you should have, I need to multiply by w to the 4th. So I'm going to subtract, w to the 5th plus 5w. I am not going to be showing as many steps from that one because that is not the focus of this lesson. But this is something we're going to come back to at the end of the lesson. Our w to the 5th cancel out, so I'm going to have minus 5w to the 4th plus 0w cubed, because we bring that down. And this time I'm going to need to multiply by negative 5w to the 3rd. So I'm going to get negative 5w cubed plus, minus 25w cubed. Here should be a 4, I'm sorry. When we do this, those cancel out. And we're going to be left with negative 25w cubed. Bring down my 0w squared. So I'm going to need to multiply by negative 25w squared. So minus negative 25w cubed plus minus, hold on. This is going to be a plus. This is a plus. So this is a plus. Oh no, it is a minus, but becomes a plus when we flip those signs. So if I go in and I flip these, it becomes a plus. So this is going to be a plus. 125. All right, so we go in, flip our signs, and we get negative 125w squared. Bring down 0w. This is going to be, I need to multiply by negative 125w. And we're going to get minus negative 125w squared minus 625w, which gets us, this flips our signs yet again. So this becomes a plus, 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 cancels out, and we're left with positive 625w. Bring down the plus 32. This time I'm going to multiply, this is going to be a big number, multiply by positive 625. And that's going to get us, I'm going to have to work it out over here. So we have 625w plus 32. We're going to subtract 625w. 625 times 5, 25, carry the 2, 10, 12, carry the 1, 3125 plus 3125. So that when we flip these, minus, 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 I'm just going to subtract 32 from this. 5 minus 2 is 3. This becomes a 12. Because I have a remainder of 3093. Wow, that is ugly. So minus 3093 over w plus 2 is my final answer. Hopefully that is the longest problem I'm doing today. That is my hope. Again, I moved this bottom part over here. I ran out of space. But that's what you should get. Moving on. I can't believe I chose a 5. Oh, I messed up. We're gonna pretend this was a 5. We're pretending that's a 5. Oops. My bad. Pretend that's a 5, and you should get your work. 1, 2, 3, 4, 5. So 2, 4, 8, 16, 2, 1, 2, 3, 4. Actually, you should have no remainder. Your actual answer. Your real answer to this problem, if you actually did this correct problem, is going to be, here's this, without all this work that I am now going to erase. That's what I actually want that. I'm gonna erase from here because I want to see that top part. All right, so your actual answer, and I'm so sorry about this. I just don't have time to go and redo this whole problem. You should have had w to the 4th minus 2w cubed plus 4w squared minus 8w plus 16, and that should have no remainder. This should have been your answer. I am so sorry. But if that was a +5, that other prop would be your work. But that's not the focus of today's lesson. I am so sorry. Reducing synthetic division. So there is actually a second handout that you were given in class that goes over these steps. Write the known 0 in the house. List the coefficients. Bring down the first coefficient. Multiply by the house number. Add as you go across and repeat. So it looks like this. So this last column is always going to be the remainder. This first one inside this box at the end is going to be your constant. This is going to be my linear term, my quadratic term, my cubic term. If I needed to, I do x to the 4th, x to the 5th, and so on. It is a count up in your exponents. So this is x cubed, counting up in your exponents. And so the best one for this one's actually to see it being happening. So we're always going to do, and if you look at this previous one, right, the known 0 in the house, the known 0 is what you get when you solve this for x set to 0. So it's always opposite of what you see. So in the house, I'm going to put a 5. I'm going to list my coefficients. My coefficients is 1, -2, -8, -35. And we are always pretty much adding, so I don't need to worry about flipping signs this time. Step 1 says bring down the 1. From here, we are going to multiply by the house number, so times 5, which is 5. We then add -2 plus 5 is 3. We're going to multiply by 5. 3 times 5 is 15. -8 plus 15 is 7. We're going to multiply by 5. We get 35. -35 plus 35 is 0. So again, this is my remainder. I have no remainder. This is my constant term, my x term, my x squared term. So my answer for this question is going to be x squared plus 3x plus 7 is my final answer. I feel like I skipped a slide. There's a few rules for this. We can only use it in certain cases. I have not skipped a slide. This is on this. This is the example that's on the actual handout itself. That was given out in class. You can only use this when we divide by a linear binomial. So my highest exponent is a 1. And in this class specifically, we're only going to do it when the leading coefficient is 1, because there's an extra step, and you can still do it, but there's an extra step when it's not 1. So we're going to go ahead and take a look here at questions 1 and 2. So 1 and 2, my known would be -8. My coefficients are 1, 3, -43. And we're going to add. So typically, this is how my setup looks. So we're going to bring down the 1, multiply by -8, get -8. 3 plus -8 or 3 minus 8 is going to be -5. We're going to multiply that by -8 and we get positive 40. -43 plus 40 is -3. So I owe remainder constant x. So x minus 5 minus 3 over x plus 8. Here on number 2, again, we're going to flip our sign. So it's going to be 7. My coefficients are 2, -16, and 19. Now you are going to find people they do slightly different setup every single time, and that's fine. But generally, this is how mine will always look before I even start it. So our step says bring down the 2. We are then going to multiply by 7 to get 14. -16 plus 14 is -2 times 7 to get -14. And we get 5. So again, remainder, constant, and n term. So 2n minus 2 plus 5 over n minus 7. As always, pause the video if needed. I do want to take a look at number 2 with you, number 3 with you. And I want you guys to go ahead and do number 4 after that. So we're going to have a 2, 1, 5, -7, and 2. Even though these say we do's, I came to the realization that because of how the examples I chose, there was a little confusion. So we're going to do drop the 1. And the confusion came from not the process itself, but from a different process towards the end. So 7 times 2 is 14, which gets me 7 times 2, which gets me 14, 16. So again, remainder, constant, y squared. So the issue I found that some people had is they were confused on which variables to use. So this is going to be y squared plus 7y plus 7 plus 16. So the previous 2 examples didn't have the quadratic term. So again, it's always a count up on those exponents. So I want you to go ahead and try question number 4. All right, let's go ahead and check your work for question 4. So we should have -4 here. 1, 9, 13, -33, -16. Going to add, bring down. This is my remainder. All right, 1 minus 4 is 5. Minus 20 is -7. That is 28. -33, so that's a -5 plus 20. Which gets me 4. So my answer here is going to be, and I always label them before I start, constant. Oh. So in this case, number, constant, or c squared, c cubed. So 1c cubed plus 5c squared minus 7c minus 5 plus 4 over c plus 4 is my answer. Missing powers. So kind of like when we did our long division, we had a missing powers. Again, we're going to use a 0 as a coefficient. When there is a missing power in the dividend, yeah. So I want to show you that for the most part. So we're going to do number 5 together. You guys are going to do number 6. Your setup for the most part is the same. You can do your countdown. 3, 1, 0. So I'm missing k squared. So we're going to do 1, 0, -17, 32. The remainder. So again, this here, if you want to go ahead, this is going to be my constant, my k, by k squared. So we bring down the 1 times -5 times -5 is 25. -17 plus 25 is 8. 8 times -5 is -40. So -8. So we get k squared minus 5k plus 8 minus 8 over k plus 5. So I'm going to go ahead and try number 6. All right, let's go ahead and check your work. So we should have 8 and then 8, -64, 0, 3, -28. Bring down the 8. 8 times 8 is 64. We added that, we got 0. 0 times 8 is 0, plus 0 is 0. 0, 3 plus 0 is 3. 3 times 8 is 24. So we get -4. So remainder constant x squared, x cubed. So my answer is going to be 8x cubed plus 3 minus 4 over x minus 8. Pause the video as needed. Oh, look at that. I didn't even realize I had space on there. Such a crazy thing. What did it say on the previous slide? It was just to go over, so I actually had space. So we actually already did those. So the next thing we're going to talk about is synthetic substitution. Did I? Oh, so this is a click through. It's beautiful. So I'm going to find f of -1. So we could plug in -1, do all that work. We get with -1 plus 9 minus 22 minus 1. And we get -24 plus 9, which is -15. Sorry, I had to find out where this is. So versus we could do synthetic division. So this would be a -1. And we would do 1, 9, 22, -1, plus, bring down the 1. Just bring down the 1. 1 times -1 is -1. 9 minus 1 is 8. 1 times -8. 1 -8. -1 times 8 is -8, which would get me 22 minus 8, which is 20 minus 6 is 14 times -1, so -14, which gets me -15 when we add. And you should notice that if we did it this way, that your answer is the same as the remainder. So it's very useful, actually. So looking at the second one, same thing, that we actually plugged in that 4, you get all those big numbers and having to combine like terms as possible. We get 23 versus we could have just done, would help if I'm actually in pin. Could have just done 4 and then 2, -30, 2. Ooh, we have a placeholder. I'm sorry. So 2, 0, -30, 2, -17. So we bring down the 2, we get 8, and we get 8 again. We get 32, which gets us a 2, which gets us an 8. 2 times 4 is 8, which gets me 10. 10 times 4 is 40. So that is 30 minus 7 is 23. And so we see again that they match. So this actually leads into our remainder theorem. The remainder theorem is when a polynomial is divided, f of x is divided by x minus c, and the remainder is the f of c. So my input is my output. So using synthetic division, we can do synthetic substitution. So using synthetic substitution, go ahead and try out the problems. Pretty much this is just extra practice on synthetic division. So go ahead and pause the video, try the two problems. All right, so let's go ahead and check your work. We should have a 5, 1, negative 13, 39, negative 4. Bring down the 1. So we get 5, we get negative 8, we get 40, negative 40. So negative 1, negative 5. So we get negative 9. So that tells me that f of 5 equals negative 9. For 4, we're going to do negative 2, 5, 11, negative 22, negative 28. We get 5, negative 10, 1, negative 2, negative 24, positive 48, so 20. So f of negative 2 is going to be 20. All right, so I'm going to go ahead and try these 4 problems. Pause the video as needed. All right, let's go ahead and check your answers. So on these, I'm really actually just going to go ahead and check what your answers are, more so than anything else. Unless I think so you should have gotten your answer for 5 is f of negative 8 equals 6. That one I'm not too concerned on. Looking at 7. So I'm just going to put the setup actually. So I'm not going to show the work by, I'm going to put the setup for what you should have had. So on 7, we should have 1, 1, 0, 7, negative 1. There is a placeholder because we are missing the x squared term. In that you should have gotten 32 here. So f of negative 3 equals 32. Over here on number 6, your setup should have been 10 in the box, 1, negative 10, 0, negative 4. You're missing the x term. And down here for your remainder, you should have gotten negative 4. So my answer is f of 10 equals negative 4. For 8, your setup should have been 2 in the box, 2, 0, negative 18, 0, 7. And for your remainder, you should have gotten negative 33. So f of 2 equals negative 33. If you didn't get those and you want more help, do come and see me. But I do want you to actually try those. It's a fairly simple way to do it. You don't have to, but it is another method for us. So application-wise, we have 2. So we have just a situation about bike manufacturer saying use the remainder theorem to find the profit per bicycle when 4 bicycles are produced. Essentially, so go ahead and try this one actually. Pause the video. All right, coming back here, what is happening is that they said your input is 4. What do you get after you put your input at 4? So we're going to do negative 1, 7, negative 5, 1, and 0 because I need my constant. So we get negative 1, we get minus 4. 7 minus 4 is 3, times 4 is 12, which gets me 7. 7 times 4 is 28, which gets me 29. And that times 4 is 116. So the answer here is your profit is $116. Pause is needed. All right, pause and go ahead and try number 10. All right, looking here, there's a signed baseball card, they're talking about value. T is the number of years since, so we do need to figure that out since 1980. But I can do this other part, 2, -48, 300, and 0. All right, so my input 2080 to 2025, so 80 to 2000 would be 20 years, plus 25 would be 45. So my input is 45. So we want to know about B of 45. So we bring down the 2. 2 times 45 is 90. 90 minus 48 is going to be 50 minus 8, 42. And now we're getting to big numbers. So 42 times 45 is 1890. 1890 plus 300 is 2190. 2190 times 45 is 98,550. So my remainder is 98,550. So that card is now worth $98,550. Pause as needed. I did say that our Bellemere was going to come back. So instead of using long division to do this problem, we're going to do synthetic division. So I would have a -2, a 1, w to the 4th, w to the 3rd, w squared, w 32. So we are going to go ahead and use the -2. I could actually even do it with the -5. So we can do it that way as well. So we bring down the 1. 1 times -2 is -2, which gets us -2, which gets us 4, which gets us -8, which gets us 16, which gets us -32, which gets us a remainder of 0. So this would be w to the 4th minus 2w cubed plus 4w squared minus 8w plus 16 as my answer. And since I made the lovely mistake at the start and I did -5 instead, or we did the 5, so I can redo it also with the 5, just to show you it also works that way. 1 minus 5 minus 5, 25, 25, -125, -125, positive 625, positive 625, -3125, and that is -3093. So that would be w to the 4th minus 5w cubed plus 25w squared minus 125w plus 625 minus 3093 over w plus 2. Yes, I was lazy when I wrote that minus last one. Just to go and show. That is our lesson. So hopefully it works out really well for you. If you have any questions, do come and see me. Other than that, good luck, and I will see you next time.